Section 9.3, the p-value approach to hypothesis testing. So this is just a second method to test a claim. What is this about? This is just, as I said, this is meant to be a second method to test a claim about a population mean mu, assuming that the population standard deviation is known. We already know it, or it will be given to us. So this is what's going to happen. There will be we're going to test a claim and see it then do we support the claim or not, and how does the p-value work. First, as we did in the previous section, we set the hypotheses H0 and H1. You know, it could be this is always mu equal mu 0, and mu is, it could be right tail test like this, or mu equals mu sub 0 and mu less than mu sub 0, or mu equals mu sub 0 and mu does not equal mu sub 0. Okay, so these are the hypotheses. It's going to be one of these conditions. And then after we do this, we will be solving for what we call it, I call it z sub 0, x bar minus mu 0 over the standard deviation over the square root of n. So we get z sub 0 first. We got z sub 0, and this z sub 0, we call it test statistic. Test statistic. And what we need to do is determine, using the z sub 0 value, what we call it the p-value. P is like it's a probability value. Okay, then we compare the p-value with the level of significance. Alpha, which will be given. If in this case, if the p-value less than alpha, we reject the null hypothesis. We reject the null hypothesis. And people call it usually decision rule. So this is the procedure. Very quick. We find z sub 0, the statistic, using this formula, x bar minus mu 0 over the standard deviation of the population divided by the square root of n. N is the sample size. Most of this stuff will be given to us. We determine using z sub 0 the p-value and table 2 for the z values. And then we just compare the p-value with the alpha that is given and see if the p-value less, we reject. If not, we don't reject the null hypothesis. And this is what the p-value is. You can read through it. And I'm going to be using the same examples from the previous section, but I'm going to repeat them again here. So in the previous section, we had an example about the U.S. Federal Highway Administration. They give us the mean number of miles driven annually, the mean driven annually is 12,200. That's for the entire population. Patricia believes that the residents of the state of Montana drive more than. So her belief is that the mean is more than 12,200. So that tells us it's a right tail test. So, and she obtains a simple random sample of 35 drivers. So 35 is n size. In the state of Montana, the mean number of miles driven for the 35 drivers, they give us the mean. That's the mean for the sample, which is 12,895.9. assume that the population standard deviation is 300 miles, that Patricia wants to test the claim at alpha equals 0.1 level of significance using the p-value. So again, the first thing we do is set the hypotheses. H0 is always mu equal mu 0, which is 12,200. Mu bigger than mu 0 is this. And we need to find z sub 0. X bar minus mu over standard deviation over the square root of n. X bar is 12,895.9. The mean is 12,200. This one is given 3,800 over the square root of 35. It was the same value we got in the previous section. So that's z sub 0. That's the z statistic that we're going to use with table 2. So let's look at the graph first before we head into table 2. This is the graph. It's almost normally distributed because n, the sample size, is bigger than or equal to 30. That's why I drew it this way. So here we have 0. Now it's a right tail test. The z's that I found, z sub 0, which is 1.08, it's this. It's this one. That's what it represents. So the p-value is basically the probability that z is bigger than z0. In other words, is the probability that z is bigger than 1.08. But to use table 2, I cannot use, the table 2 gives me to the left of z sub 0. So then I can say this is 1 minus the probability that z is less than 1.08. And now I go to the table and find this is the z value. So find the probability that with z is this. This is the z value, 1.08. So you go to the z table like this and find 1 here, or let's see. If we look on the table, 1.0, and then here you look for 0.08. Horizontally this way, vertically that way. They overlap at that point. That point is 0.8599. 0.8599. And if you subtract them, we get 0.1401. 0.1401. So that's the p-value. Now I'm going to compare the p-value that I just obtained, which is 0.1401, and the given alpha 0.1. Is the p-value less than alpha? Is the p-value less? So that means these are zeros here if you want to fill them up. Notice the p-value is not less than alpha, it's bigger than alpha. So we fail to reject the null hypothesis. Fail to reject. And how do we interpret this? We say there is no, or there's not sufficient evidence at the alpha equals 0.1 level of significance. To support the claim that residents of the state of Montana drive more than the national average of 12,200 miles. That's the interpretation. It's important to know why we're doing this. After testing this, what do we get? So there's no sufficient evidence to support the claim that the residents of the state of Montana drive more than the national average. There's no way. So Patricia said, based on her sample, she found out that the population from the sample, or actually wait, she believes, let's do it this way. She believes that the national or the drivers of the state of Montana drive more than the 12,200. That's what she believes in. She believes in this. And then what she did, she collected a sample of 35 drivers who are licensed to drive in the state of Montana. And then she ran the testing as I did. And she found out that, there's the result based on this, there's no sufficient evidence to support her claim. There's no sufficient evidence to support the claim. Another example we went over in the previous section, and what you see here on the left side, there's another example. Before we get into that one, they found, based on the information, and you can see that in the book, based on the information, they found the z value this. Then you have to go to the table 2, and find out the p-value. And then compare the p-value with the alpha. If the p-value is less than alpha, we reject an hypothesis. Otherwise, we fail to reject it. The other example we covered in the previous section talks about, according to the CTIA Wireless Association, the mean monthly cell phone bill in 2004, the mean was $50.64. That's the mean. And a market researcher believes that the mean monthly cell phone bill is different. So the mean is different today, but it's not sure whether the bill have declined because of technological advances or increased due to the additional uses. So this is saying mu is different than 50.64. To test the claim, they don't know if it's going to be the bill is going to be different or not. But to test the claim, the researcher phones a simple random sampling of 12 cell phone subscribers. So they give us N12 and obtain a data in a table that if you refer back to the previous section in the video, you see the table. We don't need the table actually. They got the information from that table. They assume that they give us the population standard deviation of $18.49. We are going to take this data. Actually, we do need the data. I'll tell you in a minute why. Data to test the claim that the mean monthly cell phone bill is different from $50.64, and alpha, the level of significance, is 0.05. We're going to use the p-value method. So how do we do this? From the table, the given table they give us, we use it to find the mean. The mean, which we found in the previous section, was 65.014. That's what we found. And now what we're going to do is, the first thing is, notice it's not given as normal distributed, and n is less than 30. N is less than 30. So what we do in this case to check if this is normal distributed, so we go back to this table, the small table, not table 2, the given table. From table we found the mean, and we need to do the normal probability plot. It's called normal probability plot. That can be done on the calculator. We did that in previous sections. So you put the data in and see if there's any outliers or not, and it will show you there's no outliers. There's no outliers, and hence based on some people call box plot, based on the box plot, there's no outliers, and hence it's normal distributed. So now we can use the z sub 0, which is x bar minus mu sub 0 over the standard deviation for the population over the square root of n. This one we found it from the given table. This one was given to us 50.64, and this one is 18.0. over what we have here is 18.49 divided by 12. If you put that in the calculator, it's 2.69. Now we need to find the p-value. So the p-value, of course, don't forget to set the hypotheses. What happens here graphically, this is what it means. 0 here, I got 2.69, but it's a two-tailed test because it says different. So it's going to be this part and this part. So it's going to be 2 times the probability that z bigger than z0. Some people put opposite value around that. It doesn't matter. The p-value is 2 times the probability z bigger than the number we got. But notice the table doesn't give us bigger than that. So what do we do? By symmetry is the same thing. So what we can do is we can find up 1 minus the probability that z is less than 2.69. And now we need to go to the table and find table 2, find what we have here. You can say less than or equal. I found 0.9964. And if you subtract them, you get 0.0036. Multiply that out, you get 0.0072. That's the p-value. Now we're going to compare the p-value and alpha. Note, alpha is 0.05 and the p-value 0.0072. What do you notice? The p-value is less than alpha, so we reject the null hypothesis. This means there is sufficient evidence at this level of confidence or significance to support the claim that the mean monthly cell phone bill is different from $50.64 than it was back in 2004. That's what it is. So there are 3 cases, either the right tail test, left tail test, which both work the same. Left tail is the easiest one. You don't have to do 1 minus, but the right one you have to do 1 minus. For the two tail test, you have to double it. So you do 1 minus and double. So as I did here. That's what the p-value is.